Welcome to Scene 1, Kite Fundamentals. Let's begin by looking at the very definition of a kite in geometry. Observe as the title Kite Fundamentals appears at the top of your screen. Now, watch as we carefully draw the outline of a kite. Notice how the shape is constructed with two pairs of adjacent, congruent sides. Next, we highlight its defining property. Here, the two sides emerging from the top vertex are shown in blue as pair 1. Shortly after, the lower pair is highlighted in red as pair 2, emphasizing their congruence. Finally, we reinforce what defines a kite. Notice the text. A kite has two pairs of adjacent, congruent sides. This statement summarizes the key property of the kite. In Scene 2, we dive deeper into one of the most distinctive properties of a kite, the congruence of its adjacent sides. Notice as the kite appears on your screen, it is drawn steadily to re-establish its overall structure. Now, observe how we've highlighted the two distinct pairs of adjacent sides. The pair highlighted in blue represents one set of congruent sides. Similarly, the red highlighted pair shows the other set of congruent adjacent sides. Now, we add measurement markers along the blue sides with the label A and along the red sides with the label B. These markers indicate that each pair of adjacent sides is exactly the same in length. Let's now zoom in on the blue side pair. Notice how the arrows and label A draw your eye exactly to this detail, reinforcing their equality. This focused view helps us grasp the concept without distraction from the rest of the shape. Finally, we return to the full kite view where both sets of congruent sides are visible. This reinforces that while we can isolate details for closer observation, they all contribute to the overall structure of the kite. In Scene 3, we take a closer look at one of the most intriguing properties of kites, the behavior of their diagonals. Notice how the shape on your screen is our kite, a quadrilateral with two pairs of adjacent congruent sides. Now, let's focus on the first diagonal, drawn in red. This line connects the left and right vertices and is special because it is bisected exactly at its midpoint. Watch carefully as the blue diagonal appears, crossing the red diagonal precisely at its midpoint. This intersection isn't arbitrary, it perfectly slices the red line into two equal parts. At the point where these diagonals meet, a dot appears. This is our cue to recognize that something unique is happening here. To further highlight the geometry, we see a curved arc marking a 90-degree angle. This arc confirms that the diagonals are perpendicular, meeting at a right angle. Let's take a moment to reflect on this. Not only do the diagonals intersect perpendicularly, but the blue diagonal neatly bisects the red diagonal into equal halves. Now, let's explore an essential aspect of kites, how the geometry of their sides and angles provides unique properties that help us compute their area. Here on the left, notice how the kite's shape is constructed by two pairs of adjacent, congruent sides. As we trace over the shape, focus on the two angles where these sides meet. Observe these arcs. They highlight the fact that the angles between the congruent sides are congruent. We label them simply as theta. Building on this visualization, let's shift our attention to the calculation of the kite's area on the right. The area is given by 1/2 the product of the diagonals, written as area equals 1/2 times d1 times d2. Notice how two dashed lines now emerge to represent the diagonals. One of these diagonals is perfectly bisected by the other due to the kite's symmetrical properties, and the lines intersect at a right angle. Watch how a slight change in the lengths of d1 and d2 would affect the resulting area. Welcome to Scene 5, Circles and Special Cases. In this segment, we're going to explore the conditions under which a kite can accommodate circles, specifically when it can have a circumscribed circle or an inscribed circle. Let's begin with a basic kite. Here, you see a generic kite with its unique property of having two pairs of adjacent congruent sides. Take a moment to notice its shape. Now, consider a special case, a square, which is a type of kite with all sides equal. Watch as the square appears at the center. Notice the inscribed circle that fits perfectly inside the square. This demonstrates that only in a square, a very specific kind of kite, can we draw an inscribed circle such that the circle touches all four sides uniformly. This property uniquely distinguishes the square from other kites. Next, let's turn our attention to another special case, the rhombus. Although it shares some properties with our kite, its slanted structure allows for a different circular relationship. Observe the circumscribed circle now appearing around the rhombus. The circle is drawn such that it touches all the vertices. This exemplifies that only a rhombus, or in special cases a square, can have a circle drawn about it that exactly fits around all its vertices. By contrasting these examples, we can firmly grasp that geometric circles in kites are a matter of specific symmetry and congruence. The generic kite stands alone, while only the square and rhombus reveal these additional circular properties. Building on what we've learned today, we can now see how small variations in a shape's properties lead to entirely new geometrical insights. Let's move forward with this in mind as we explore more in our next segment.